Hello, students. Let us learn arithmetic progression for the day. And let us first understand what is arithmetic progression. Try to go through the definition. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term, except the first term. Yes, I know math being a tough subject just because it is a dry subject where we have no fun in that. But to be frank, it's fun of numbers. An arithmetic progression, as you go through the definition, an arithmetic progression is nothing but list of numbers in which each term is obtained adding a fixed number. Let us come out with an example. Let me take 2 as my first number and keep adding 2 to the preceding 2. It's like 2, add 2 to it, you're gonna get 4, and add 2 to that, you're gonna get 6, add 2 to that, you're gonna get 8. Just like that, we can take any number. Let me take 10 as my first number, keep adding 5 to that. It's like 10 plus 5, it's 15, add 5, it's 20, add 5, it's 25. It just goes on, something like this, a pattern where we add a constant number to the first number to get the next and the next and the next and the next is called arithmetic progression. Okay, I hope you understood the definition of arithmetic progression. Let's come up with a few points as I blabbered. Here we have it written where we can note it down. In the arithmetic progression, a fixed number is added to the preceding number to get the succeeding number, where we call the fixed number as common difference. Yes, the common difference or the fixed number can be positive number, or it can be a negative number, or even it can be a 0. If I need to give an example, let me take 2, keep adding 0 to it. 2 plus 0, it's 2. Again add 0, it's 2. 2, 2, 2. Okay, it is in a pattern where I can predict the 10th or 15th number or even the 100th number, just telling that add 0 until you get the 100th number. Yes, so the fixed number can be a negative number, a positive number, or even a 0. I hope you understood the definition of arithmetic progression. Yes, let's get into much deeper into arithmetic progression. Here, the first term, what we call the fixed term, we name it as A1 or T1, where it is just to represent the first number of the progression. And coming to the next, it's like A2 as usual. If the first one is A1, the second is A2, and the third will be sure A3, and it just goes on. Yes, so then the AP can also be written as A1, A2, A3, and so on. AN means it's the last number, where N stands for any natural number. So it may be hundredth, thousandth, or even infinite. Yes, let's go ahead with the definition. According to the definition, each term is obtained by adding a fixed term. So that fixed number is named as D. It is denoted by the English alphabet D. Yes, coming to the next part, A1, that is initial term A. Yes, A2 can also be written as A1 plus D, because to get the second number we are adding some constant to your previous number. Yes, and the third number A3 can also be written as A2 plus D. A2 is nothing but the preceding number and the fixed constant is D. When you add it, you're gonna get the third number. By just expanding A2 we have already mentioned it as A plus D, where we have done with the same A plus D copied down and the D carried forward, where it can also be written as A plus 2D. A3 can be written as A plus 2D. Yes, coming to the next number, A4. A4, as we know, it's like add constant number to your previous number. The constant number is D, the difference, and the previous number is A3. Me trying to add D to your previous A3, so which cannot, A3 can also be split and written as A plus 2D from the previous step, and add D to it, you're gonna get A plus 2D plus D, which is equals to A plus 3D. Yes, by now you'd have understood. I'm going ahead with A10. It's like A9 plus D, where A9 can be written as A plus 8D. Then A10 directly can be written as, it's 4, I've written 3D, it's 3 and I've taken 2D. Here it's A2, we have 1D. Here it's A10, so I have 9D. A plus 9D. True, the general term of arithmetic progression is nothing but A plus n minus 1 into D, where n stands for any number. Here, for example, let me go with, I want A100. If it's A100, I can write it down as A, the first initial number, plus, since here 100 minus 1 from it, we're gonna get 99, multiply it with the constant number d. So this is what the given arithmetic progression's general term means. An is equals to a plus n minus 1 into d. Yes, this is also known as the formula. We consider it to be the formula to find any number, any term in a given arithmetic progression. If this is the general term, the next, for sure, yes, it is general form of arithmetic progression. First number can be written as a, the next as a plus d, and the third is a plus 2d. Obviously the fourth will be a plus 3d. Then 100, it's a plus 99d. Then 1000, it's a plus 999d, and so on. Students, I hope you have understood the arithmetic progression. If you really like, and if there is any suggestions to update on my teaching, please try to leave your comments in the page. Thank you. Okay, now let's start with the question from your textbook. It's like example 1 from AP 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. Write the first term a and the common difference. Yes, the first term as we know, in the arithmetic progression, the initial number, the initial term is the first term. So the value of a is 3 by 2, and there was for common difference. Common difference, take any number, subtract the previous number. It's like 1 by 2 minus 3 by 2. Let's go with the solution. Yes, first term is a, 3 by 2. The common difference is nothing but any number. That is, I have chosen 1 by 2 minus the previous number. It's minus 3 by 2. Where it's the denominators are already equal, we go ahead with subtract it, minus 2 by 2, and I'm going with reduce it to the simplest form where both are divisible by 2 table. We have minus 1. Yes, if I'm too fast in teaching explanation, please leave your comments so that I'll reduce my speed. But being math the dry subject, let us try to finish it fast. Yeah, coming to the next question, which of the following list of numbers form an AP? Yes, which of the following list of numbers form an AP? If they form an AP, write the next two terms of it. Coming to the question here, 4, 10, 16, 22. Let us check if this is in the pattern of arithmetic progression. To check if it is in arithmetic progression, what are we supposed to do? Yes, you are right. Take any term. I chose 10 and I subtract the previous number, that is 4. 10 minus 4, we have 6. Yes, and I take 16 and subtract the previous number, that is 10. 16 minus 10 gives me again 6. Let me try with the third one also. Take 22, subtract minus 16, which is equals to 6. Since the common difference are equal, we conclude that the given equation, the given question is in arithmetic progression. It is in the pattern. Yes. Let's move on to the next question. Here you have 1, minus 1, minus 3, minus 5, and so on. Okay, the procedure is the same. Let me consider the second number or the second term of the given progression, minus 1, and subtract the previous one. I guess we know that it's d1 is equals to minus 1, and this minus is for the term, it is already with the term, and this minus from the formula, and this one the first term. Minus 1 and minus 1 is equals to minus 2. Now the d2, we take minus 3, subtract the minus 1, the preceding term, minus 3, and we are supposed to subtract minus 1, where we end up with minus 2 again. Okay, the last number, that is minus 3, the third number. Let me take third number and subtract the previous minus 3, where it is minus 5 plus 3. Minus into minus is equals to plus 3, where the final answer is minus 2. Since the difference, the common difference is common, is constant, therefore the given progression is also in arithmetic format. Okay, done. Let's go with the third question. Yes, the given numbers are in AP. Coming to the next question. Minus 2, 2, minus 2, 2, minus 2, so on. Is this an arithmetic progression? Yes, let me try to Let us try to find the value of d. It's 2 minus of minus 2 is equals to 2 plus 2 is equals to 4. Yes, we have chosen 2. Subtract the negative 2. Yes, 2 minus minus 2, minus into minus, which is equals to plus, where the final answer is 4. Now we'll take minus 2 and subtract the previous term, that is plus 2. Minus 2 subtract plus 2, where we end up with minus 4. As you can see, this is positive 4 but this is negative 4, where d1 and d2 are not equal. Therefore, yeah, right, it's not in arithmetic progression. Coming to the fourth question, 1 1 1 2 2 2 3 3 3. Yes, it is not in arithmetic progression. The reason, yes, the difference between this two numbers and the second two numbers are 0, but the difference between the fourth and third is equals to 1. d1 is okay, d2 is okay, then d3, yes, d3 is equals to 1, where d2 and d3 are not equal. If you're supposed to find if an arithmetic progression, a progression is an arithmetic progression, we need the difference to be common throughout the progression. But here, the first two gives 0, but the third difference gives us 1, where d2 is not equal to d3, therefore it is not in arithmetic progression. Yes. Coming to the next.